Welcome to part 3 of the SAJC H1 Physics module. Now we're going to cover part 3 of the dynamics lecture. In this part we are going to cover Newton's third law and provide examples on Newton's third law for a better understanding. Right, so that was Newton's first law. Now let's take a look at Newton's third law. What does Newton's third law state? It states that when two bodies interact, the force exerted on body A by body B is equal and opposite to the force exerted by body B on body A. So this basically states that if you have one force that pushes on another body, that body will push back the first body with the same force. They are both equal and they are opposite. Now let's look at an example of this beautiful lady who's pushing on a wall. Now you can see that as she is pushing on the wall, there is a force on the wall. Now the wall will exert an equal and opposite force back on the skater. So you can see that both these forces are equal and opposite. So by the definitions we had earlier, now we know that forces always exist in pairs. Now these are action-reaction pair. You have one force exerted by the person, and you have the wall acting back on the person. So that becomes one action and one reaction pair. Now, one other thing to note is that the forces act on different bodies. When the person is pushing on the wall, the force is acting on the wall. Now when the wall pushes back on the skater, it's actually acting on the skater. So you can see the two forces act on two completely different bodies, although they are an action-reaction pair. So let's look at a couple more examples. Now we all are walking every single day. We wear our shoes, we are walking, but every time we take a step, we have forces acting as we walk. Now the shoe on the ground, you have actually, when you start walking, you have the shoe pushing on the ground. That's the force of the shoe on the ground, and the ground will act against the shoe, and so you have an equal and opposite force acting on the shoe, which is the force acting by ground on the shoe. So as you walk, these two forces always exist, and that's how we start moving. So the shoe actually acts on the ground, and the ground acts on the shoe. It's an action-reaction pair acting on two different bodies. Now another example, if you take your hand and you slam it against a piece of wood, now you always feel it's very painful. Now what exactly happens is that when you hit the table, there is actually a force from your hand to the table, and the table has an equal and opposite force acting on your hand as an action-reaction pair. So you can see that the hand has a force on the table, and the table has a force on the hand, and these two forces are of course acting on different bodies. Now that's very important to know. So by now you must be obvious that it's impossible to have a single force acting at any one time. Forces always exist in pairs as an action and reaction pair. Now let us take a look at a complete system. In the example below, you can see an assistant pulling a sled along the ground. Now let's look at the forces existing between the man and the sled. Now as the man is pulling the sled, he exerts a force on the sled, which is represented by FSA, and the sled exerts an equal and opposite force on the man, represented by FAS. Now this forms one action-reaction pair. Now if you look at the next contact force, which is between the sled and the ground, you can see as the sled is moving, the sled exerts a force on the ground, which is represented by FGS, and the ground exerts an equal and opposite force on the sled due to friction, which is represented by FSG. Now this forms another action-reaction pair. Now let's look at the forces existing between the man and the ground. Now as he's walking on the ground, he pushes on the ground with a force which is represented by FGA, and there's an equal and opposite force from the ground on the man represented by FAG. Now these two again form another action reaction pair. So in this system you can see there are three action reaction pairs, and in your questions when you deal with Newton's third law, you must be able to identify the action reaction pairs correctly to answer the questions correctly. Now one of the most common errors that students make is to assume that the weight of the body and the upward contact force that the body has with another object are an action reaction pair. For example, if you put a book on a table, students incorrectly assume that the contact force of the table on the book and the weight of the book are an action reaction pair. Now these are two different types of forces, so they are not going to be an action reaction pair. Now if you take the whole system and you take the book, the table, and the table acting on the ground, now if you take them apart, now these are the lines of forces that you will see acting on each of the bodies. Now how do these forces come about? Now let's look at the book first. Now when the book rests on the table, it has a contact force between the book and the table. Now the book acts on the table, which is the normal force from the book on the table, and you have an equal and opposite force from the table acting on the book, that is acting upward on the book. So these two form an action reaction pair. The two blue lines are the action reaction pair of the normal contact force between the two objects. Now what about the other force that is acting on the book? Now the other force is the gravitational attraction between the book and the earth. So because of the two different masses, the book will attract the earth and the earth will attract the book. So these two forces are action reaction pair. Now let's look at the table at this time. Now if you look at the green lines, now these are the normal contact forces acting between the table and the ground. So when your table is resting on the ground, it will have a contact force with the ground, which is the normal contact force. So you can see that force acting downward on the ground, and the earth has an equal and opposite force acting on the table, which is the normal contact force from the earth on the table. So these two form another action reaction pair. And the last one is the attraction between the table and the earth. Now the earth has a mass and the table has another mass, so there is a gravitational force between the table and the earth, and these two attract each other, so they are an equal and opposite force due to the attraction between the two masses, and so they form another action reaction pair. So in total you can see that there are four types of forces acting in the whole system. Now each type of force, each action reaction pair is one type of force. So you can see between the book and the table there's a normal contact force, and that's one type of force. You have gravitational force between the book and the earth, that's another type of force, and between the table and the earth there's another contact force, which is between the two of them is the same type, and the last one is the gravitational force between the table and the earth, and that's also of a gravitational force acting. So every action reaction pair is of the same type. You cannot have an action reaction pair of two different types, and you cannot have a force of two different types and call it an action reaction pair. So if you have gravitational attraction between two bodies, now that's one type. If you have normal contact force, that's another type, and they must be of the same type for you to call it an action reaction pair. Now this is the end of part 3 of the 4-part lecture. Please go on to the last part of the dynamics lecture.